Hey everyone, this is Matt with Learn Everything About Design, and in this video, we are going to tackle some design for 3D printing inside of Plasticity. Now, this is a question that I have got several times, and I have done a video in the past on using Plasticity, an older version, albeit, but using Plasticity for 3D printing. There have been some updates. We're using version 24.1.1, and in this video, we're going to go through a project creating a Super Mario question block that is 2 pieces, and there are going to be some push buttons that allow us to open it. We're going to go through the process talking about things like 3D printing tolerance, how to use geometry to cut away other geometry, and talk about sort of fit and finish and gaps that we need. Now, of course, everybody is going to have their own opinion on ways in which we can model things and whether or not these tolerances work. So we're going to cover some general terms. We're going to talk about how to figure this out for yourself and hopefully give you enough information to make your own parts. Do remember, if you are purchasing Plasticity, we are an affiliate. So if you use the code LEAD10 at checkout, you'll save 10% and it will help out the channel as well. So to get started, we are going to begin by going to our preferences. I'm going to be working in the metric unit system, in this case, millimeters. We've got grid size and accent lines. Again, I've talked about this in the past. I don't generally care about these because I'm either going to use numbers and not snap to grid. If you like to snap to grid, then make sure that you do customize yours. Again, this doesn't really matter for me. I can set these to whatever number I want, and it doesn't really affect me. What we do need to make sure we understand is that the default settings are going to be in the meter unit system. And if we delete this cube, the numbers that we use are going to be now very tiny relative to our screen size. So the way that I like to start a design like this, because we're going to be working with specific numbers, is to hit 7, which is the top view. I'm going to start a center rectangle. So hold down the left mouse button, grab center rectangle, go to the origin, hit tab, and then enter your dimension. So in this case, 50 millimeters, tab, 50 millimeters, and hit enter. Then we're going to use the /, which will allow us to zoom to our selected object. It's automatically selected after we create it. And now we're looking at about the right scale for both our view and the object that we're working with. So now that we're at the right scale, let's go ahead and just take a second to talk a little bit about tolerances. This is a very important topic, and every 3D printer is going to be a little bit different. So depending on what 3D printer you're using, you're going to have to do your own testing to figure out what numbers work for you. Now, I am using a Creality K1 Max, and what I have found personally is that using the Hyper PLA material, my parts come out a little bit undersized. The general tolerances that go along with these FDM machines are usually around plus or minus 0.2 millimeters. What I'm dealing with on my machine is actually an undersized part. It's pretty consistent at about 0.1 millimeters to 0.2 millimeters. Now, I say pretty consistent. There are going to be variations based on ambient temperature, whether or not on my machine the lid is off, and how hot the build chamber is. Those kinds of things all are going to affect these sizes. So my suggestion is to do a couple of test prints. And what I like to do is make just a simple 2 millimeter thick plate that has a couple of hole sizes in it. I like to do 10 millimeters because it prints pretty quick. I'll do a 10 millimeter hole, a 10.1, a 10.5, and a 10.75, and just kind of print a boss that's 10 millimeters and see what fits for you. Now, for me on my printer, going to a 10 millimeter boss and a 10.1 millimeter hole gives me a really good tight fit between parts. Going to a 10.5 millimeter hole gives me a loose fit. So when we're talking about snap fit parts or parts that need to sort of nest together, these are the numbers that I generally work within, somewhere between 0.1 and 0.5 millimeters. Of course, this is relative to the scale of your part. As your parts get bigger, you might notice that the tolerances get to be a bit bigger as well. So when we're talking about something about 25 to 50 millimeters in size, I aim for the 0.1 on the tighter side to 0.5 on the looser side for my fit. If you want to go bigger than that, if you're dealing with things like threads, then obviously you can play around and figure out what numbers work for you. But doing a couple test prints is always a good idea, especially if you have to fit parts that are not printed to 3D printed parts. Because again, These are coming in undersized, and if they fit together, that's not a big deal. But if you are trying to get them to fit other things that exist in reality already, then it can be a bit tricky and you might need to start scaling up your dimensions. Okay, so that was a lot of talk on numbers. We'll come back to that when we have the parts that need to fit together, but let's carry on modeling. So now that we've got this sort of rectangle, the square, we're gonna begin pulling it up. I'm gonna hit Tab, which is going to allow me to sort of make this centered. It says lock distances in the bottom right, but basically what we're doing is a center line extrusion. And then we're gonna use 25 millimeters for the distance, because hitting Tab makes the other direction, in this case negative Z, opposite or exactly the same, but in the opposite direction of the value that we entered. So we have a 50 by 50 square, and we want it to be 50 tall, making it a perfect cube. Right click to accept. Then we will select and delete the rectangle. We don't need it. So now that we've got this cube, we're going to work on edges, box select everything, and then we want to add some chamfers to this. The size of chamfer doesn't really matter to me, but you can use -3 by -3. That's probably a good number for this size object, and that'll give us those sort of squared off corners. You could add fillets if you want to, but generally those don't print nearly as well as chamfers do. So especially on objects like this, I prefer to do chamfers. And if I'm going to be filleting, generally I try to keep them in the XY direction. They print a lot better that way. Let's go back to our all selection, which is 5 on the numbers at the top of the keyboard, or if you want to use Tab, that'll also do that as long as you're not currently in another tool. So now that we've got our object, let's get started making the question mark. So this can take a good bit of time, but there's a little bit of a shortcut we're going to do. We're not worried about precision here. I'm going to select this face, hit the space bar. I'm going to zoom in a bit, and then I'm going to go back to my center rectangle. Just find a spot up here and create a rectangle that's going to be the overall width of the upper portion of our question mark. Now, if you need to move it around, you can use G and Z and kind of reposition it a little bit. I would caution you against moving it in the X direction since we snapped to that Y axis. I'm going to do another one. Find roughly center. Now, if you want to, you can find the midpoint here. You can tap shift and find true center. You don't really need to for what we're doing, but if you want to. And with the question mark block, you typically have a thinner section at the top and thicker on the sides. So just do this visually, not using numbers. Right click to accept. Then we'll use our line tool from the midpoint, bring it down to where you think the question mark should end. Left click to accept. And because this is going to be easier to see, let's go ahead and hide the block. And now we want to take this line, hit O to offset, begin pulling it out and hit Tab. And just kind of make it visually the same as the width of the side. Right click to accept, delete that vertical line, and then we're going to use the line tool a couple of times here. Remember, shortcut keys like Shift and A for the line or Shift and R to repeat last command are going to be pretty helpful to know. We're going to finish that off, and we're going to go up here, finish that off, and then we're going to use T to trim. I need to get rid of this piece, this one, and that one to make our question mark. If you want to, we can also get rid of this little line and extend this out. So for example, if I delete this, I can move this line up. I can hit G, begin pulling it up, and I can hold down Control and snap to that endpoint. And that's going to give me a nice clean line segment here without that extra spot. Select everything and hit J to join it together. Then in our corner rectangle, hold down the left mouse button and tap shift, come over here, tap shift again, right click, and now basically we have everything. I'm going to move over to my vertex selection, which is 1 on our numbers. I'm going to box select everything, and then I need to remove a couple. So with these question mark blocks, the outside corners here are going to be a larger chamfer. So I'm going to hold down Control, deselect those, and deselect this one as well. Then B on the keyboard. And what we want to do is we want to create a chamfer, right click to accept, and then go back and select all the ones that we didn't use. So holding down the shift key, then B on the keyboard, and add the larger chamfer there. There are plenty of other ways that you could have done this, but I find that using the center rectangle and the corner rectangle are by far the quickest, but you could sketch this out any way you wanted to. play around with the scale of it, but I think this looks pretty close. It's not perfect, but if you want to make any adjustments, we can select vertices and do GX and kind of move things over. And we'll do the same thing over here, GX, and maybe move some of these, GX, kind of pull it out. Again, doesn't need to be perfect, but play around with it and make sure that you're happy with the shape. Once you are, go ahead and get off of your temporary construction plane. Go back to the all selection, which again is tab or 5. I'm going to bring back this block just so I can see it. And I'm going to begin extruding this out a very small amount, let's say 0.5 millimeter. Now, the reason for 0.5 millimeter is it'll be big enough to be visible, but small enough that it's easy to print. I'm going to use 3 on the numpad. And I know I've had a lot of comments lately on people that are using laptops without numpads. If you need to configure your own shortcut for that, hit F on the keyboard, start to type in view, and you can find which one of these options you need to change. So for example, navigate to the right view. You can right click and you can assign your own shortcut that works. Another thing that you can do is hold down the Alt key, and then you can just sort of press down the middle mouse button and move left and right, up and down, and that'll let you get to those views without having to use another shortcut key like the number 3. So just keep that in mind. There are a couple ways that we can do it. We're going to go to our edge selection. You may want to zoom in. I want to grab just the outside edges, rotate, and then add a very small chamfer. The reason that I want to do this is because, one, it's going to make it a bit easier for us to print. So even though it's only 0.5 millimeter, when we are printing geometry out in space like this, having it taper out, but also having it be as minimal as possible is certainly helpful, especially if the bottom edges are tapered, because as it starts to print, it'll build out a ledge for it to print on, and this will give us a better result overall. It's not going to be guaranteed, but that's generally what I like to do with something like this. We're going to right click. While they're still selected, I am going to use a radial array. Select this top center face of my cube and make sure the number is set to 4. I think it defaults to 8. So if you happen to see 8, just change it manually or drag it down to 4. Right click to accept. Now, we're not going to start joining anything together yet. There are a few other things that I want to make sure that we do. First, let's go back to our all selection. And then we want to make sure that we can split this up. So I'm going to go to a front view. Again, it's 1 on the numpad, or if you're using a laptop, just hold down the Alt key and use the middle mouse button until you get to a front view. It can be a side view. It honestly doesn't matter. I want to figure out basically where this line needs to be, somewhere between here, and just kind of draw it out to the left. Then I'm going to take that endpoint, G and X, and move it out to the right. Now this is going to be my split line. Now with it selected, let's go ahead and select the entire line, C on the keyboard to cut, and cut this block. I don't need the line anymore, so we can go ahead and delete it. And what we have at this point is a top of the box, a bottom of the box, and then all of these question marks. Now I'm going to go ahead and double click over here and call this the top. It'll be much easier for us. Call this one the bottom. That way when we start hiding it, it's going to be much easier. So I'm going to select the bottom, hit H to hide. I'm going to select this bottom face, and then F, and start to find hollow. When we're using hollow, a positive value is going to make it a shelled body on the outside and a negative value on the inside. I'm going to use a 3 millimeter wall. It's probably overkill for this. We could make it thinner, but that's going to give us enough material to play with because we are going to add a couple of extra features. So now I can hide the top, bring the bottom back. We'll select this face and search for hollow again. And again, the value is going to be -3. So now we've got a hollow bottom and a hollow top. What I want to do is select all the bodies on the top. If you go from the bottom right to top left, anything the box crosses will be selected. If you go top left to bottom right, only things that are completely encompassed are selected. So again, we're going to go ahead and grab all these, hit Q on the keyboard twice to join things together or union them. Right click. Now the top should have all those question marks on it. The bottom is a little bit trickier because we're going to use 2 of these question mark dots, basically these periods, as push buttons to release the bottom from the top. So 2 of them are actually going to be joined to the top and 2 of them are joined to the bottom. Because of that, I'm going to select the bottom, hit Q, select this body, shift select this one, hit Q again, right click to accept, hide the bottom and bring the top back. So in order to join these together, I'm going to have to make these much thicker. So I'm going to select the inside face, begin pulling it out, hold down Control, and select that edge. This is going to allow me to make it in line with the inside edge of the box. Right click to accept, and we'll do the same thing over here. So begin pulling it out, hold down Control, and snap to that edge. Now you can see here, if we take a look at this, that's going to be perfectly in line with the inside of the box. There's a lot more work for us to do because we have to make a thin tab section here that's going to allow us to flex that, and then we're going to have to create geometry to remove from the bottom. Depending on how you want to approach this, you can either do it one of 2 ways. You can start to remove the material from the bottom now, and then you can begin sort of customizing the offset values you need, or you can wait till the very end. I prefer doing it now while the geometry is a bit more simplified. So what I'm going to do is select this bottom, hit Q. I'm going to shift select both of these bodies, but we want to use the T option to keep tools. So T on the keyboard, right click to accept. And now if we hide the top and these extra little extruded pieces, you'll see that we've got a perfectly matched opening. Now remember the values I talked about initially. 0.1 millimeters, at least on my printer, is a fairly tight fit. 0.5 millimeter difference is going to be a much looser fit. For something like this, we want to be somewhere in the middle, and I'm going to use tapered geometry to kind of take up that extra space. You don't want it to be a perfect fit. You probably don't want 0.1, so somewhere like a quarter, 0.25, that's probably going to be a good value. Now, I know that we're sort of cruising through this, but there is a lot to get through. You can certainly slow down the video if you need to, but let's just pause for a second and let's just review what we've done. So we made the initial block. We used a sort of 2-point rectangle, made it 50 millimeter by 50 millimeter, and then we extruded it from the midline, a total distance of 50 millimeters. Grabbed all the edges, added our bevel, and then we worked on making the question mark. Now, a question mark comprised of a couple of different lines and center point rectangles, and then we trimmed everything until we were happy with the size and shape. The next thing that we did was we began adding or joining things together once the body was hollow, and then we kept 2 of them separate because we're going to use them as push buttons that are connected to the top block. Now, at this point, the push buttons are exactly the same size as the hole in the bottom, which obviously isn't going to work. So we will need to address that. But for right now, let's hide the bottom and let's focus on combining things together. One thing that we want to do is we want to create a thin section that will allow us to flex this push button. Now, the amount that you need to actually make this happen is going to depend on your material. It's going to depend on how big the object is, obviously. But we made a 3 millimeter wall. What I'm going to do is create a 1 millimeter section, give it a little bit of gap to allow it to flex, and then join it to the bottom of the body. When this thing gets 3D printed, it's going to print upside down. So we can print that thin wall coming up, no problem. And this bottom, because of these tapers or chamfers, that's going to print just fine. In most cases, most 3D printers will print 45 degrees without any issue. You don't need supports to make that work. And because the question marks are so thin, 0.5 millimeter with small bevels or chamfers on them, then we don't really have to worry about any supports there as well. So to make this happen, what I'm going to do is I'm going to select this top face, hit spacebar to create a temporary construction plane. This is going to give me access to things like the inside edges automatically, as well as the outside edge. So this can be very helpful, especially if you need to use those inside and outside edges. The next thing I'm going to do is select this body and use Alt-D, which is an alternate duplicate. Now, what this is going to do, if we rotate this around, is it's actually going to take the silhouette of that body and push it down. Now, the main reason that we want to do this is going to give us a few things. It's going to let us know exactly how wide this object is, and it's going to allow us to use some of those edges if we need to. So what I'm going to do is hit spacebar to go back to that view, and I'm going to hide this object because I don't need to see it right now. And then I'm going to make a line from here to here, right click. It's automatically going to be selected. So we can use G X, and 1 millimeter. Now, as we look at that, that 1 millimeter is probably too thin. So I'm actually going to make it 1.5 millimeters, which will be half the wall thickness. That's how big the piece is that's going to connect the push button to the rest of the body. But we also need to remove material. We're going to have to leave a fairly thin wall here to allow that to flex. So what I'm going to do is hit Shift D to duplicate that, hit X, and 0.5 millimeter. This gap is going to be plenty big for us to 3D print. We don't have to have a perfect fit between those two parts, and it's going to give me enough space to allow me to 3D print. If you want to make it bigger, if you want to make the walls thicker, you certainly can do that, but we're going to work with these smaller numbers. This button only needs to flex inward, so toward the center of the box, and this will give us two profiles that we can select. One that'll allow us to extrude or cut away material, and one that'll allow us to add material back. One thing that we should also consider is the sides of this are perfectly matched or the exact same size right now, and we do need a little bit more of a gap over there. So using the line tool, we can create a line again from here to here. Let's actually just go here, G, Y, and -1 millimeter. And then we're going to do the same thing on the other side. I use Shift A, shortcut key for the line, G, Y, and +1 millimeter. And then you can either extend these edges of these lines or you can connect them all together. So for example, I can go from here to here, right click to accept. Then I can use my line tool again. And actually, let's hit escape. Let's go ahead and delete this line. We'll go from here to there, right click to accept. And now we've got this profile that we can use for the cutaway, basically removing material. And then we've got this profile here that we can use to add material. I'm going to go ahead and rotate this or sort of zoom out. I'm going to hide this object, so H on the keyboard. And I want to take everything I have here and mirror it to the other side across X. We could do this with a solid body, but generally with these types of features, we want to remember or make sure that we are capturing that data on both sides, whether it's with curves or solid bodies, it doesn't really matter. We're going to hit X to get off our construction plane. Then we're going to remove material. So select the profiles you want and go ahead and grab these. I'm going to do the other side at the same time. So this one, this one, this one, this one. Almost sounded like the Mario song. All right, and we're going to bring this down, pick a distance, let's say 10 millimeters. We are going to also use Q because we want to remove it from this body. And you can see what's happening in the preview on the screen. If we right click, it added it. So Control Z to undo. We're going to go down a distance of 10 millimeters. Let's go -10 and hit Q and then W for the difference. So generally, when we use the Boolean tool Q, by default, it's going to remove. But when we use it during an extrude feature, you need to remember to hit W for the difference, just because by default, it won't join the solid bodies together. So when you use it during an extrude, you will need to make sure that you manually pick that you want to remove that. Now that we've got that section, I can hide some of these curves. They're not needed. I only need that sort of inside section. So basically this one here. So you can select curves, hit H to hide if you want to. This just kind of cleans up our selection a little bit. We don't have extra profiles that we're able to select. And now we just have this one here that we need. So let's bring back those two extrudes. And now what we want to do is connect them together. So select the profiles you want. Go ahead and grab this one here as well, Shift select. And we are going to drag this down, holding Control and snap it to here, but we want to go in two separate directions. So this one here, we want to connect. We can take it up further than needed simply because it can overlap and it'll join just fine. We do need to make sure that we go up past those bevels or chamfers, depending on what you want to call them. Now, for me, from CAD, they're chamfers, but I know a lot of people do call them bevels. Let's go ahead and hit Q and then select the bodies that we want to join together. Now, for some reason, that preview went a little crazy. If that happens, just hit escape and let's go ahead and extrude them one more time. Begin dragging this down, hold Control, snap to here, go in the other direction, just make sure that they do overlap. We'll right click to accept. I'll hide all the curves, and then let's just join these together. We'll need to grab this as well, Q and Q, and now we should have that one solid body. So again, when we're 3D printing, this will be perfectly fine. I do think it's important to remember that we are going to be dealing with stresses on this body. So at this corner, you may want to add a small sort of chamfer there to bevel it. There's not a whole lot of room there. It's kind of hard to see. If we turn off our faces, it might help see it a little bit. It really doesn't. So you may want to add a bevel here just to give it a little bit more strength. And we want to add that to both sides as well. So I'm going to come over here, hold down Control and grab this one. And I'm going to use minus 0.5 and minus 0.5. And basically all we're doing is we're trying to give that a little bit more strength because we are pushing these away. Another thing that we need to consider, and I'll bring the faces back for this. Another thing we need to consider is this bottom edge is basically hanging out in space. Printing that is going to be difficult. So we probably want to either add some sort of chamfer there or add something else that allows us to print that a bit easier, because this is going to be an overhang and that is problematic. So make sure that we just add some geometry. We don't want it to overlap, but that will probably give us enough to print there. I'm going to go ahead and pull this over, hold down Control and select that one as well. And now we've got our push buttons. The next thing that we need to deal with is going to be the space in which those fit, but also we need to remove some material now because of that chamfer we added. Let's go ahead and on the bottom, I'm going to hit M for material. I'm going to go to opacity and I'm going to turn the opacity down to say 30% or 40%, and then left click on the render mode. And that'll go to that opaque view. And it's going to be kind of hard to see, but let's zoom in here. So basically what we have here is the push button, and we've got this sort of tapered section we just added, but it's going into a solid block. So we need to remove a lot of material to make this work. I'm going to turn off render mode so it's not transparent anymore, hide the top block with H. And now what we want to do is select this face, space bar, zoom out a bit. And now we want to remove material to give it enough, sort of enough space that it can attach to that. I'm going to do this with a center point or a corner rectangle. I'm going to start from that center point here and sort of drag this up and out. I don't care so much about these dimensions, but it is important that we know how far we're sort of going here. So if you need something like that, you can use the line tool. You can start here, hit tab, and remember that we went 1.5 millimeters for the block on the bottom, plus we added a little bit of extra because we removed 0.5 millimeter. So we went 2 millimeters. If we go 2.5 millimeters, that takes away almost the entire wall. We can kind of see where that falls. So that will allow us to move this entire object, GX, and just kind of drag it to the right, leaving a very small amount of material here. Now, printing a thin wall like that could be problematic, but we're doing it for two reasons. One is because we need this thing to be able to help center itself and help deflect it when we're inserting it. And making this section fairly thin will also help us allowing that section to deflect a little bit as well. Again, with your own printer, you need to play around with how much material you need in these areas. You may find that printing out a couple of different lids is needed to make that work. But I'm going to take this, I'm going to mirror it across X so we have it on both sides. I'm going to select both profiles after we get off of this. So we'll select this profile and this one and begin pulling them down. Control and snap to that face. We're going to use W for difference. And now we're able to remove that. I don't know if I need these rectangles at all, but let's go ahead and just hide them for now. And if we need to, we can taper this edge, but it's so thin, I really don't think that we need to do anything there. But let's go ahead and bring the bottom back. Let's remember that these are the exact same size. So we do need to account for that a little bit. Let's hide the top one more time. And let's think about our tolerances here. Now, remember I said that on my specific printer, it's printing undersized by about 0.1 millimeters at a 10 millimeter size. When we go to print this, we want to make sure that we think about where we want the extra space. We don't need as much extra space on all sides, and extra space on the top will help us more than extra space on the bottom because we want this thing to fit together kind of tight. So when we're playing around with these values, we can remember that the outside of that question mark button is tapered, so that'll help it sort of self-center. And if we want to offset the sides, we can simply take these walls and begin offsetting them, but notice that it leaves those chamfers in place. So you want to make sure that you select enough faces to make this work. So Control and begin pulling these out a distance of minus 0.1. This is going to give us an overall gap of 0.2 millimeters. And the reason for that is because we're offsetting it on both sides. So we're going to go ahead and do this here. Again, minus 0.1. That's going to leave the top and bottom the exact size. And because of the taper on the outside of that question mark block, this will help us get a fairly tight fit. There is going to be one or two more things that we need to do before we print this though. So let's go ahead, select these, start to drag them out. You could do multiples at the same time, but sometimes it's just easier to work your way around and just do them one at a time. Because there's no history here, only thing it affects is if we have to undo all these at the same time. All right, and now if we bring the top back, we should see a very small gap. Let's go ahead and look from here. So top and bottom exactly match. The sides now have a small gap, which will allow it to move a little bit. And because of the chamfer or that taper on the outside of these, it should help us align. One of the good things here is we can always sand or file or trim down the plastic a little bit if needed. We can't really add more plastic back to it after we printed it. So generally I err on the side of caution and make things a little bit tighter, knowing that I can drill holes out or I can sand things down to make them fit a bit better. The last thing that I will say with this design is it might be helpful for us to have a locating feature between the two bodies. You don't need it, especially if the tolerance is fairly tight between these little push buttons here and the bottom piece. But if you want to have locating features, you can do a very small lip. So what we would do is, let's go ahead and hit spacebar. We're going to select maybe the outside edge or select this face and hit O to offset. And what I'm going to do is just offset that. Let's see, right about there, it's minus 0.88. The inside one isn't needed, so I'm going to delete that. And I don't want this lip to be everywhere. We could put it on just the sides, but putting it underneath this is going to be problematic because remember, we do have that sort of big chamfer there. So what you might want to do is extend these lines out, spacebar to go back to this top view, Shift A for my line tool, and just draw a line forward. Shift A again, or again, Shift R to repeat. We'll go over here, do the same thing over here, Shift A or Shift R, and one more time. So now this should give us a couple of little sections here. And what we can do is we can either pull them up to add a little bit of a lip or pull them down to add a little groove for that bottom piece to snap into. Again, it kind of depends on what you're doing, whether or not you want to have this locking feature. I'm not going to include it in my version because I think those tabs are going to be tight enough that I'm not too worried about it, but that is something that can be helpful. Another feature that we may want to consider, let's go ahead and just hide all these curves with H, is on the bottom piece, let's go ahead and rotate this around, we may want to taper these edges. So as I'm going to go ahead and rotate this around, I'm going to hold down Control and select these. We may want to do that because again, it'll help self-center and align those a little bit. Then we can right click and accept. This is going to be a very thin section. We have to be aware of that. It's not going to be super strong, but we could make changes, of course. We could make concessions. We could pull this in. We could reduce the overall size of the chamfer that we have on the bottom of the other feature. But for the most part, that works pretty well. If you want to add any other details, say if you want to model a gold coin in here or a mushroom or something, then you could certainly add that to the 3D print. For now, what I'm going to do is I'm going to save this, and I'm going to call this our QMark block box. I did do a previous test and 3D print of this just to make sure everything did work. So I do have this body now. When I send this to the 3D print slicer, if I export the entire design, what we're going to end up having is going to be problematic. So what I like to do is rotate them into the orientation for 3D print and save another version of this for 3D print. So that way I have both versions. So I'm going to take this part, I'm going to rotate, we're going to rotate about, let's go ahead and rotate about X, 180 degrees. And then we're going to do G. I'm just going to move it off to the side for right now. We're going to do G. We're going to do freestyle, move this face down to match this face. And then from a top view, we'll just kind of move them into an orientation that we can 3D print. So now they're both on the same level. I can 3D print them both at the same time if needed. And then we can do a save as, question mark, block box, print. You don't have to save this version, but it can be helpful to have an upside down version of it. And then I just need to save either the OBJ, STL, or depending on your print slicer, save a step file. I'm going to use an STL for a couple of reasons, which we'll talk about in a second. And that is going to be this density here. Now for our part, it's honestly not going to make much of a difference. If you have a part that has circles in it, if they have cylinders, holes, things like that, then this density is going to be a big thing that you want to play with. Generally, when I have round parts, I crank it all the way up to 1, make it a pretty high density model if I'm going to be 3D printing it. That way I know that the resolution of the circle, the cylinder, the boss is going to be high enough that I'm going to get them to fit together pretty well. Again, it's not required, but when you do have round parts, that is helpful. The next thing for me is to bring it into a print slicer so that we can send it off to be 3D printed. Again, I am using a Creality K1 Max, and I'm using Creality Print. I have played around with a couple of other slicers like the Orca slicer, but I've just found that I've tweaked the parameters in Creality Print, and I just think they work a little bit better for me. You can, of course, use whatever slicer that you want. This one just happens to work okay for me for right now. So let's go ahead and open this up. This is going to be our QMark block box print. And then we can slice it. Currently, I'm running things a little bit slower. I have noticed some issues with this portion of the 3D print on the outside of the wall, so I've slowed it down quite a bit. So it's about 2 hours to print this. I could certainly print this a lot faster. I'm only running at about 25% the speed of the machine. But for the purposes of this, I think that's fine. What I want to look at here is just to make sure that we have enough clearance between this, especially when we start to get to that taper. It's going to be critical that it doesn't get joined, and it looks like it's fine. Looks like those traces are fine. And the other thing that we want to take a look at is the thin section down here. It should be 2 walls. But keep in mind that that is going to be bridging completely open. That certainly can be problematic. We may need to add a little bit of support there to hold that. I think we're going to need support there, but everywhere else should be fine. So what we're going to do is I'm going to go into the slicer, go to support, and let's see, I want to go to advanced and add tree supports, support branch angle, that's fine. Density's fine. Diameter, that's fine, that's fine. Diameter angle. Overhang angles is 60. Let's take this up to 80 degrees. And let's go ahead and slice that and see if it adds it just in that one spot. I think it's going to try to add it over here to these, which I want to avoid, but it may be okay. Let's see. Yeah, okay. So that gave me the tree supports just in the areas I needed. And now if we're looking at slicing, we'll be able to port those areas without them breaking. And now we can go ahead and send this off to the printer and see what it looks like. All right, so now that this thing is printed, how did it work out? Well, as we can see on the surface, we do have some irregularities, and this is a 3D print setting problem. It doesn't have anything to do with the model itself. But I would say that the gap on the left and right of the little push button that we made could be a little bit tighter. We added, I think it was 0.1 to both sides, a total of 0.2. I think we could have halved that and done 0.05 on both sides. Again, that's going to be very much dependent on your 3D printer. It doesn't have as much to do with the 3D model as it does to do with how close and accurate your 3D printer is. The push buttons work as expected. They flex in just enough, and the supports held up just fine, so it was able to print those little pieces. And overall, I think that this box works pretty well. It could use a couple of different updates, so if you were going to refine this, I would likely add that lip to the inside, at least in the corners. That would allow you to have a little bit more of a sort of a firm shut position where you can't really move it around too much. But overall, other than doing some refinements on the 3D print settings, I think that this is a success. So if you want to see more videos like this, please leave a comment below. So if you have any questions on this or want to see more in plasticity, please let me know. As always, thanks for watching, and we'll see you in the next one.